Okay, don't look at my hair, look at my DKG. Yeah, the backbone of my web tree. Yeah, so many brothers, mothers, fathers, daughters relying on me. I'm a Trinidad man, I come from Trinidad. I wanna be a dad so bad, but I gotta build a foundation. So I buy some track to fund my nation. Do you have a DKG? Yeah, do you have a DKG? Hello, my OriginTrail pioneers, you beautiful people. What you guys been up to? I know you guys have been partying, drinking after all that OriginTrail pumps. Now we need to settle down and get back in class, kids. Let's start learning about the OriginTrail expansion, this massive expansion that's about to take place. But before we dive into this topic today, which is, of course, NFTs, we are also going to be shouting out one of our most prolific NFT content creators, Eye of the Beholder. If you guys have not seen him, check his content out. You know, he does some great stuff. Also, check out OriginTrailExplain.info, created by none other than Mr. Kirk. Great content, great stuff. You know how we do it. Let's go. Now, today, of course, we are going to be talking about NFTs. The role of NFTs. Now, before we dive into this, let me say we're going to have this into three pieces. We're going to be talking about NFTs, what they are. We're going to be talking about the role of IPFS in today's current NFT ecosystem. And then we're going to be talking about how OriginTrail will be supercharging the punks, the apes, all these fantastic crypto assets. What is the difference between OriginTrail and IPFS? And why OriginTrail is actually an amazing addition to the NFT ecosystem. As you can see here, we are on the CryptoPunks page and we have a whole bunch of different assets here. You know, CryptoPunks have been selling for insane amounts of money. If you don't believe me, let's check it out right here. As you can see, we're gonna go to the activity and yes, 31 minutes ago, this CryptoPunk sold for almost 400,000 Boneros, bro. Broneros. It sold for almost 400,000 Broneros. This is spectacular. All right. So the kind of value being transacted in the NFT space right now, clearly it's real. It's not that there is not that entities do not consider this to be valuable. But you know what? We're not going to be talking about all the moon boy aspects of it. We're going to be trying to stick as technical as possible so that we can keep this video down to a certain length, but even the technical stuff is kind of crazy. So what we see here, let's click into this exact CryptoPunk, for example. We're going to first establish the different layers that we see here. We see an image, right? And we also see some information about this particular image. This is metadata. We also see some cryptographic information, which means this requires a blockchain, hence smart contract. So we know we're getting immutability from blockchain, and we know we need some sort of storage service, be that centralized or decentralized, for these images and metadata. So let's tackle the first component of this, storage. And storage really tackles as I said, the images and the metadata. Now, traditionally, I could say, let's say I put this image up on a website. I decide to host my own server and I put this image there and I store the metadata there and I reference my information correctly. And what happens if my server goes down? Well, that's the problem with using a centralized service. All of a sudden, my NFT has no image. Of course, my cryptographic proofs will still exist on blockchain, but when you try to look at my image via those proofs, you see nada, impanero, nothing. Today, we're going to be learning from IPFS on how we can tackle these issues today with decentralized storage. Let's begin. First, they start off with a little bit of explanation on what NFTs are. It says, first, each token has a unique ID that distinguishes it from all other tokens. This is in contrast to a fungible token like Ether or Ethereum, which exists as a quantity attached to an account or wallet. There is no way to tell one ETH from another. Because each NFT is unique, they are owned and traded individually, with the smart contract keeping track of who owns what. So if we head back over to our CryptoPunk example here, The smart contract, this says owned by this particular blockchain address. And if we click this address, we see that this address owns these other wallets, and they even own an ape. So the smart contract for this particular CryptoPunk NFT is controlling who owns what, right? So let's head back over to the article. It says another key feature of an NFT is the ability to link data that is stored outside of a smart contract. Storing or processing data outside of a smart contract is known as being off-chain. Because data that's stored on-chain needs to be processed, verified, and replicated across the entire blockchain network, it can be very expensive to store large amounts of data. So if we head back over to our friendly CryptoPunk here, we can see that this is why we would want to use a centralized or decentralized storage service for these particular assets, because when you have to replicate it, it's going to cost a lot on the blockchain to do so. So now when you put that into context and you go to OpenSea and then you see all these different projects that may have 10,000, 20,000 copies, 100,000 different copies for each individual project, oh my God, you can see that this would literally explode a blockchain. So you need to have this storage on some sort of service that is off-chain. And this is why people employ services, decentralized services, and centralized services. So let's head back over into this article to see what else we can learn about NFTs. It says, this is a problem for many NFT use cases, especially tokens that represent digital collectibles or artworks, where storing the entire work could cost the equivalent of millions of USD. Can you imagine trying to put all this data on the Ethereum blockchain when gas was like 5 million guai? No, that's not happening. So this is where we start getting into the topic of content addressing, because as we saw, those images will not be replicated across the public blockchain. So we either store it in a centralized service, right? Which would give us an traditional HTTP address. Let's see what IPFS has to say about that. With an HTTP address like so forth, anyone can fetch the contents of mynft.jpg as long as the owner of the server pays their bills. However, there is no way to guarantee that the contents are the same as when the NFT was created. The server owner can easily replace with something completely different at any time, causing the NFT to change its meaning. So this is a problem without the immutability. So even though we can store it on a centralized implementation, if there is no verifiable data immutability, if we can't verify that this image is the same image, well, my friend, that's a problem. Or maybe I can edit it and then swap it out for anything and then pretend it's the same. No, we cannot have that. The image itself needs to be the same over time. It needs persistence. Now that's going to be a very important word for you to hold on to, but that's the concept of persistence, maintaining the contents, the integrity of something in that state for a long period of time, for as long as possible. Even you want it to even last forever if you can, but with the nature of technology and how things change, it's usually hard to build something that can persist into 50 years. Maybe in 50 years we'll be talking like this. Who knows? Who knows what we'll be doing in the future? Like, who knows, right? So this is why persistence is a very hard issue, but very important thing to understand. It says IPFS solved this problem thanks to content addressing. Adding data to IPFS produces a content identifier, CID, that's directly derived from the data itself and links to the data in the IPFS network. Because a CID can only ever refer to one piece of content, we know that nobody can replace or alter the content without breaking the link. So it has that same sort of blockchain cryptographic immutability because this is hashing. So it has that same avalanche effect. If you change one pixel, if you change one bit of this data, it's going to avalanche into an entirely new different hash. So not good. well, it's not good for whoever's trying to steal the data, but it's good for me in preserving the quantity, the integrity of my NFT. So IPFS, this is the power of this. This is the power that IPFS brings to NFTs. But of course, any system can really do hashing, so that's really not too impressive. But when IPFS becomes impressive is when you combine it with decentralization and participation. So it says, using the CID, anyone can fetch a copy of the data from the IPFS network as long as at least one copy exists on the network, even if the original provider has disappeared. That's important. Persistence over time. This makes CID perfect for the NFT storage. All we need to do is put the CID into an IPFS URI, like so, and we have an immutable link. I'm currently accessing this server called Pinata, which is an IPFS storage cloud-like interface, kind of, a window into IPFS, a gateway. And I've uploaded an image, and as you can see, this is my CID for this image. So I can uniquely identify this image by the CID. And if I click here to view it, what we see is the gateway via Pinata Cloud is referencing the exact same CID. And this is the image that she drew, one of my favorite One Piece characters, Zoro. Now I've also gone ahead and uploaded some JSON at this particular gateway, and we can this is just example JSON from an NFT website we will be looking at. So how does IPFS work? Really quickly, we're just going to read this. Files uploaded to IPFS are split into smaller chunks, distributed across multiple computers, and assigned a hash to allow users to locate them. Rather than using a familiar location-based link like normal web pages, IPFS links are based on the unique hash identifier of each item. That helps locate which node or nodes have the file or website available. It's then served to the user via a peer-to-peer connection similar to BitTorrent technology. IPFS isn't based on blockchain, but it is similarly immutable. The concerns cannot be changed. How otherwise the hash itself would change. So IPFS is a BitTorrent-like service that allows you to access immutability without really having to pay the cost of blockchain. So it's a scalability tool, sort of, for the storage of blockchain. But you still need blockchain for smart contracts and automated ownership and all of this sort of things that we see with the ability to trade. So it's important. So blockchain is still king in this world. So now we're going to jump over to NFT School to talk a little bit about metadata. What is this metadata thing? Let's dive. Metadata is the data that provides information about other data. In the case of an NFT, it describes that NFT's essential properties, including its name, its description, and anything else its creator feels is important. In many cases, an NFT's metadata also contain links to the images and other primary digital assets that give an NFT its value. Let's head back over to our beautiful CryptoPunks. Right? The same CryptoPunk that we've been talking about all day today that sold for almost $400,000. Oh my God. When we talk about the descriptions, what is this? Well, we see the properties. This is the metadata. We see metadata being pulled in to explain and give the beauty, the uniqueness to this particular NFT image that is cryptographically secured. Typically, your metadata will be in the format of JSON. Now, if we go back to what I said earlier, remember I said I uploaded some JSON? Well, here is that JSON. This is what that looks like. But let's dive back to NFT School because it does give some good examples of JSON. Now we're gonna dive into the different types of NFTs because there are ERC 721 NFTs and there are also ERC 1155 NFTs. Now, ERC 721, what is it? NFTs grew out of the Ethereum community, and the ERC 721 proposal was the first formal standard for interoperable NFTs to be widely adopted. Most of the standard is devoted to smart contract interface. That is, an ERC 721 token must adopt, but there is also a recommendation for a baseline metadata scheme. And as we can see, this is the JSON file the exact same JSON file I copied and I uploaded to my particular JSON file here. So basically, I just copied the ERC 721 standard documentation and uploaded it. Now, if we go to the ERC 1155, this is an upgrade to the 721. And as we can see, there is some extra fields down here, and this property fields allow you to add more extensible properties to your NFTs. Now let's see what OpenSea has to say about this, because OpenSea offers a very great example about how all of this ties together now. So how would NFTs go from IPFS, storing all of your images and all of your data here, and then you have your you have your JSON and you have your image. How does it go from living in that immutable state to something like OpenSea? Well, let's go. OpenSea says for OpenSea to pull in off-chain metadata for ERC 721 and ERC 1155 assets, your contract will need to return the URI. Remember, that's the persistent identifier for your metadata. Okay, and it says to find this URI, use the token URI method in ERC 721 and the URI method in ERC 1155. Let's take a close look at this right here. So we have our NFT trying to be uploaded to OpenSea. We have the ERC 721 contract, and what's this? We have the token URI, which returns a string metadata. So what we see here is this is the blockchain smart contract, right? And remember, we were on the CryptoPunk website. We see the owned by. This is being pulled by the token ID. So this is all governed by the smart contract. And so where does the metadata come from? Well, we have metadata. The metadata is pulled from the token URI field for OpenSea. Now, what we see here is within the same metadata, what do we see? We see the name, we see the description, we see the external link, we see all the beautiful things down here that made your NFT unique, that made your NFT beautiful, that showed us how rare it may or may not have been. So all of this comes together now to create this. This is how we then utilize all these different components. Instead of using location-based addressing, using content-based addressing by IPFS, and by using blockchain to control ownership and trading, all of this comes together to be leveraged by platforms like OpenSea, Rarible. All these different NFT platforms have their own way of digesting these metadata. All right. And right here it says to give your items a little bit more pizzazz, we also allow you to add custom attributes. And as you can see, we have a whole bunch of different attributes here. The mouth is surprise, the level is 5, the stamina, personality. This is what we're talking about, customizing your NFTs for its unique, artistic, creative content. Okay, now we're going to talk about where OriginTrail is going to start fitting into all of this. Now, on OpenSea's website, it says IPFS and Arweave URIs. OpenSea supports the storage of NFT metadata in decentralized file networks so that they can't be modified by a central party. This means any decentralized storage, as long as it can digest those URIs or resolve those URIs, it can be used as a form of storage. It says here, the world's first decentralized knowledge graph organizes your most important assets, making them discoverable and verifiable using groundbreaking decentralized network. So we're going to talk about how OriginTrail makes them discoverable, and then we're going to talk about how it makes it verifiable. But in talking about it, it kind of does both at the same time. Now we know that based on the OriginTrail technology stack, we know that the consensus layer, the blockchain layer, is separate from our network layer, which is separate from our data layer. But all we really need to focus on here is the fact that our network layer is separate from our consensus layer. So you don't have to worry about the high explosive cost of trying to upload tons of images directly onto a blockchain, because no, you're uploading to our network layer. Our nodes are decentralized across the globe, and it operates at Fortune 500 standards. You know, it's fast. It's as fast as any traditional ecosystem or computer network, because it doesn't have to wait for the blockchain layer consensus to absorb all of that data.
Yeah, so the data is in the nodes, but you say now if we would deploy the contracts on Ethereum, which are now on Ganache, it would actually be on Ethereum and like Polygon, because you had like 2 EVM chains, but also the proofs would be inserted now into the blockchain, correct?
Yes, so the proofs and certain identity information, but basically kind of a minimum set of information, because the idea there was that we build without burdening the blockchain too much. It's a constrained machine, right? Block space is very limited. That's why all of these gas prices are so high. So putting a lot of data on blockchain doesn't make sense. And then, even if you could, it doesn't provide the necessary structure to support all of these standards that we talked about.
So we're talking about being able to actually absorb all of this data in the same way like IPFS with no issues. All right, so we have the scalability that IPFS brings, but not only do we have that, we have the consensus layer right below here, and it's blockchain agnostic. So that not only means we are allowing you to access assets or issue assets across one network, you can do it across any network that we're connected to. So it brings IPFS and the power of every single blockchain known to mankind to your fingertips.
So let's see again. So now it's sending an export request. Now the node goes into the actual graph and exports the full data set. And as you can see, this is the node I'm connected to. So it's basically giving me back the whole data set. But what it also gives me is additional information. So when I export the data set, I get all the necessary cryptographic proofs, fingerprints on the blockchain, which blockchain it is. And with this, I can actually verify all the signatures. I verify the issuer, I verify the integrity. And actually, I have Merkle proofs. So I can take a piece of the data set and verify that it actually is part of the data set. So kind of like you can verify a transaction is part of a block on a blockchain.
Fantastic.
So this has been the sort of the start.
That is fantastic. Yeah, I mean, I totally get it. This is like IPFS, but with IPFS, it's not really connected to the blockchain as far as I know. It's just as, you know, IPFS nodes share with each other. Here I can publish something and it gets printed on the blockchain, like the cryptographic proof just gets printed, and then I can get it back. I can verify that the data is. So this is like, I mean, what we've seen right now is only the start, but this is like IPFS on steroids. But
as an NFT content creator or an artist, you're gonna want that level of flexibility to deploy anywhere. And the data, and we have not even began to talk about what the data layer is and the power that will bring to your NFTs. We're just talking about the infrastructural stuff here, guys. So this isn't even what OriginTrail will be doing to Supercharge. This just makes it even easier for you to do what you already do today. The data layer, which hosts the decentralized knowledge graph, which is distributed across all the network's nodes. Now, this is where we get into OriginTrail supercharging the punks, the apes. This is how we're going to be supercharging them, by making them, as based on the OriginTrail website, by making them discoverable and verifiable. So how does OriginTrail make these assets discoverable? Well, the OriginTrail decentralized knowledge graph makes these assets discoverable by placing them into a knowledge graph. Let's watch this video explaining what a knowledge graph does, who uses knowledge graphs, and why it's important.
The physical and digital worlds are largely disconnected, and we still have to switch in between the two on a regular basis. There is the physical world we interact with daily, including art, healthcare, fashion, education, or supply chains. And then the disruptive digital concepts like blockchain, smart contracts, metaverse and NFTs, and DeFi. But what can tie the physical and the digital in a single connected reality? OriginTrail is the world's first decentralized knowledge graph, organizing humanity's most important assets and making them discoverable, verifiable, and valuable. Advanced knowledge graph technology currently powers trillion-dollar companies like Google and Facebook. By reshaping it for Web3, the OriginTrail decentralized knowledge graph provides a crucial fabric to link, verify, and value data on both physical and digital assets. Forming the semantic layer of Web3, it's driving network effects through the synergy of knowledge graphs and blockchains, which enables Web3 builders to organize, discover, and verify anything. World-class companies are already using OriginTrail to create value for their ecosystems. For example, OriginTrail is enabling frictionless international trade for over 40% of US imports by fostering secure exchange of security audits. The same semantic fabric of the decentralized knowledge graph protects pharmaceutical supply chains, or can be used to organize blockchain data for seamless access to DeFi decentralized applications. The OriginTrail decentralized knowledge graph, powered by the Track utility token and a global network of nodes, is used by leading global organizations and is now ready to bring trillions of assets into the metaverse. This way, assets get to be structured, linked, persistent, and understandable, transitioning from physical to digital, from data to assets, and from Web 2 data silos to the semantic Web 3.
Let's dive into the OriginTrail documentation. It says the OriginTrail decentralized network is an implementation of the OriginTrail DKG. With the ODN, therefore, you can query for data across a multitude of systems. This is what is considered discovery. To exchange it via several data exchange protocols and integrate it with your own local knowledge graph or data store. The act of querying for data across a multitude of systems is the act of discovery. Now, when these images are on Pinata Cloud or IPFS, you can't query it. It's basically dumb data. They're not really connected to other data sets in any sort of semantic way. You're not gonna type into a Google search, give me the NFT data for whatever product. You can't do that. You have to have the CID, the ID that uniquely identifies it, and it's pretty dumb. You can't search that interface. So when we talk about querying, we're going to be, so when folks launch their own OriginTrail nodes and people launch and connect this data and post to the OriginTrail decentralized network, they're going to be searching across the entire decentralized network in a way connected by these RDF triples, which makes sense to you. Now, if you do not know what an RDF triple is, I am sorry, but I do not have the time to dive into that right now. Pause right here, watch this video, and then come right back. So these RDF triples are what's going to make your NFTs more discoverable. And in fact, let's dive into this right here. It says the public knowledge graph is used to enable data discoverability by hosting a decentralized index of information replicated across the network, enabling queries through its discovery protocols. Once information is discovered in separate private graphs, data exchange protocols are used to obtain full query results. An example of a data exchange protocol is a data marketplace protocol implementing trusted data for tokens exchange.
But also, and as I mentioned, it is coming up in the upcoming releases, there's actually marketplace features. So what we called this private data, we actually call it permission data. And that means it's behind some sort of permissioning system. So the permissioning system would be, for example, like you mentioned, these 3 nodes with these Ethereum wallets, they can access it. So I can give a list, and it's basically identity-based access control. Another type of access control is saying, if somebody's going to pay me, I don't know, 1 ETH for this, I'm going to let you take it. So it essentially is a marketplace type of feature. And basically this there's a bunch of routes through this API where you can basically get the price. As you can see, you can purchase a data set. Basically, you purchase the data set based on a data set ID that you discover on the network. And you actually have a seller node ID that you ask for. You can even ask for a specific object in the graph. So think of it as buying information like on, let's say, a car. You could have a data set, a lot of cars. I don't have to buy the whole data set. I can actually buy just a piece that's interesting to me.
And of course, it goes on to explain the roles of the OriginTrail Decentralized network. Of course, we have our data creators, our data holders, data viewers, and data publishers. Take some time to catch up because we don't really have time to dive into the mechanics of the OriginTrail Decentralized network, but it's there. Now, check this line out. It says, currently, data providers need to run their own DC nodes to publish data to the network, which is about to change in version 6 with the introduction of gateway services. So this means now you may be able to just run your OriginTrail node, and there may be some framework or some layer above that allows people to post to the OriginTrail Decentralized network to gain immutability and share tons of data without actually launching a node themselves and having the stress. So this brings even more access, I would say exponential access to the network, because it's removing the need for the technical, it's removing the technical barrier. It's like taking your weights off. You're like showing your power now, right? Anyone can access the network. What does this mean to people who aren't already running OriginTrail nodes? Why would you care to leverage the service? Well, therefore, a dataset published to the DKG by a DC node, one, contains a cryptographic identity, DID, of the DC and DP rooted in one of the supported blockchain networks. So remember, that could be any blockchain network that we're connected to that you decided to leverage. Is structured as graph linked data, so now it becomes discoverable over the decentralized knowledge graph and gains all the properties of the knowledge graph. Has a corresponding set of cryptographic fingerprints, graph marker roots, stored immutably on a blockchain. Is timestamped and has a data lifespan on a network. Is randomly replicated across pairs based on a DKG content addressing scheme. So the OriginTrail Decentralized network also leverages the same concept of content addressing that IPFS does, but it also adds all these extra layers with blockchain support innate to the ecosystem, but not just innate blockchain support. We're talking about every blockchain support. So it's really designed to encompass the entire ecosystem, be that Binance Chain, Solana, it don't matter. As long as you're currently EVM compatible, I believe it will be able to extend to that. And Brandamed did state that they are bringing non-EVM compatibility soon. So this is not just about Ethereum. We're talking about global and total domination. And to let this sink in a little bit further, because we've been talking pretty abstractly about this public layer, let's take a look at the actual data structure on the OriginTrail Decentralized network. Okay, so it says OT-JSON, a data structure guideline. It says it has one-to-one convertibility from JSON, XML, CSV. So this means that you're still able to put the properties for your NFTs, the same metadata, in JSON, and it will convert automatically to OT-JSON, which is digestible by the OriginTrail Decentralized network and decentralized knowledge graph, which turns it into graph data pretty much. Okay, this is in the graph. So this is the public graph, what you're going to be searching to find your particular item or whatever you're identified by. So we can see here we have this graph data, and the ID for this particular product is product 1. We have the type, it's an OT object because it's in OT JSON form. So it's this product itself is one individual object, and it is specifically identified by its identifier value. And this seems to be a supply chain item because it has this EAN. And as we can see, we have the properties about this particular item in the graph. And we see here we have the name, quantity. But where have we seen this before? That's right. We have seen this in the metadata example for OpenSea. It's pulling the name and it's pulling information about the particular item. So in the same way, we can have the properties about a particular NFT item in the graph, be that all the colors and attributes. For example, if we scroll down, all these different colors and attributes linked in the graph, and its relation could be produced by. So it's saying that this item here, product 1, its relation is producer. So this product is produced by the producer of producer 1, whose ID is producer 1. So what's the properties? It's produced by. So let's say this producer is famous Amos, baby. Let's say I'm the NFT creator and the relation is produced by. So now you can go into the centralized knowledge graph. Now but not only do we have the information about the product, we also have the information about the producer. So this producer, let's say Chillzone, is also an OT object because I live in the graph as my own identity, uniquely identified by this identification number. And these are the properties that I may have. Maybe the Chillzone, the name of it is Chillzone, and I, instead of wanting to use a geolocation, I may want to use a web URI that uniquely points you to my website or something. I don't know. Anything you want to put in here, baby. You know, baby, let's grow. Let's figure it out. Let's see what we want to put in here, baby. You know what I'm saying, baby? All right. So and I itself can be related to all of my individual NFTs, showing that these are my assets. Now, this, my friends, is so revolutionary in so many ways. You may not even understand that yet. So let's see one example, just one, because we don't have time. This video is probably going to be one of my longest videos ever, and I still haven't even really discussed all that I want to put in there. And as you can see here, we have an issue in the world where there isn't really a way to validify the authenticity of your NFTs. Today, the way that they recommend verifying your NFT is real is, you know, you go on Google Images to reverse image check the image. You go check the social content of the creator. You check to see if the creator is selling on other platforms, and you check to see if it's cheap, and all these different sort of detective works that we just don't need to exist. What can happen is we can have a platform where these content creators sign up, and you then take the unique identifier for your particular NFT on that blockchain and you put it in there and you verify, boom, verify via the OriginTrail Decentralized network. This NFT is authentic because it is produced by the Chillzone and it's verified by his identifier. So all of these things kind of come together, and because it's blockchain agnostic, it makes it the Google, so you don't have to, it's not going to be a service that's limited to just querying on Ethereum or Binance Chain. It's going to be able to query across every NFT platform on every blockchain, everywhere, across every network, across the entire globe, bringing validity to the entire NFT ecosystem, supercharging these NFTs, if you will, in that particular fashion. This is just one example I thought up. Like, I don't even, I'm talking about you can even start building, because the OriginTrail decentralized network is separate from the blockchain layer. We're talking about even the ability to facilitate trading activities, which means you can even build cross-chain, multi-chain trading platforms, and of course, anchored in the blockchain. So to close off, we're just going to take a quick look at the public graph.
One thing is, what if I have some data that is private, like we discussed? I guess you can you specify a specific group of nodes that I only allow it to, or maybe we don't have to write it in code because maybe it's more complex, but can you just talk about how, if I don't want to share, because with this, like dkg.publish, if I connect to a public node in a production environment, it will be spread everywhere, right? So how do I connect to, don't spread it everywhere, basically?
Yeah, it's a very good question. Actually, probably the best way to illustrate is through the API. So basically, I'm not sure if Postman is something you're familiar with, but basically it's a tool to interact with the DQG API. And here we see, actually, it's even more powerful than the client that I just shown. So there's two answers to this. One answer is each node is able to import a data set which has a public and private component. This public component is intended to be used as metadata, as really, and this keyword, Google keyword type of a thing. So you would have this public part of the knowledge graph, somebody can find something, and then this can reference to something that's within your private domain. And that's up to the implementer. So it can be like basically any URI, it can be a service that exists behind some sort of access control.
So it says the structure of a dataset consists of a dataset header, dataset graph, and a dataset signature. The dataset header contains the dataset metadata, such as the dataset timestamp, data creator information, transpiler information, verification schemes, and versions. So let's check what this looks like. So as we can see here, we can see that we have the dataset header. We can see the OT.json version. We just talked about what OT.json is. We can see the timestamp creation for that data set. We can see the dataset tags. Now, if we know about V6 and DKG topics, this is where you start putting in your Google-like tags so that when somebody searches on the OriginTrail Decentralized network for a certain tag, yours can pop up. And based on how many people have been looking for that particular tag, just like Google page ranks, yours will be listed first in the rank. So it's like you can build a platform literally like a Google search interface. I'm not even joking, a quite literal Google search for NFTs and anything like it. This is you can see all the data sets that these NFTs or whatever is related to. You can see how it's validated. You can see that it's ERC 725, whatever. Your contract address. You can see the proofs. You can see the data creator and all these additional informations. And of course, this is how we merge the discoverability of the decentralized knowledge graph with the verifiability of all the cryptographic proofs anchored in blockchain and these decentralized networks, bringing together the beautiful power, leveraging decentralized knowledge graph to supercharge NFTs, bringing true discoverability in a very Google-like way, bringing true verifiability because it is all in one package. All of the security and immutability is all packaged into one locale, one domain, and one interface. And before I close, actually, I have one more idea. We can be building the Google Analytics for NFTs because right now, across the globe, we have sales going on between all these different punks. But what if there is a pattern? What if all the red NFTs have been selling for higher prices than blue background NFTs? What if certain names have been selling for higher than certain names? Well, the decentralized knowledge graph will allow you to put all of these different things across every blockchain, across every network into a graph so you can actually build Google Analytics for NFTs in a very real way. Because, well, if you're able to identify which ones sell best, you're able to then offer recommendations. So this is where I think we can even see things like Amazon. You know how Amazon has those little recommendation palettes for you? You can even see the decentralized knowledge graph being leveraged by different stores, different marketplaces to offer recommendations, which is built by Amazon's knowledge graph. So guys, the future is bright. OriginTrail is now. Web3 is now. We are now. We are not the next Quant. We are not the next Ethereum. We are not the next Polkadot. We are OriginTrail. The world's first decentralized knowledge graph. That's what we are. And there will be many more that try to be like us, imitate us, but we have that first mover advantage. We've been pushing, and this community will see the success of our technological implementation and innovation. I'm sorry that this video went on for so long, but this topic really needed some love, and I actually left out quite a bit. So guys, Smash the like button, smash the share button. I'm sorry for taking up all your time, and you guys keep it beautiful, keep it sexy, and stay beautiful.
Okay, don't look at my hair, look at my DKG. Yeah, the backbone of my web tree. Yeah, so many brothers